So good morning, everyone. Thank you all for attending today. We're here to discuss a novel approach to detect and quantify 41 clinically relevant sexually transmitted infections, including both high and low-risk HPV. Although sexually transmitted co-infections are common, most commercial assays only target one or a few STIs at a time. The ChapterDx HPV STI assay can detect up to 41 different STIs in a single tube and in a single sequencing run. However, before we get into more details around this assay, let me briefly introduce myself and the presenter. So my name is Jean, and I work in the diagnostic division at Separations, who are the local distributors of ChapterDx here in South Africa, as well as a few other African countries. Our presenter, Dr. Baback, is the co-founder and chief scientific officer of ChapterDx, and has many years of experience working with technology and assay development at Stanford University. He is one of the pioneers and co-developers of pyrosequencing technology, working on both chemistry and applications. He developed long-read pyrosequencing from a few bases to over 150 bases, which opened the way to enable pyrosequencing to be used for NGS. Pyrosequencing at the time of invention was the only other sequencing method next to the traditional Sanger sequencing approach. He also invented a patented multiplex sequencing assay for detection of multiple HPVs and STIs in a single tube pyrosequencing assay. He co-invented and co-patented an HPV microarray assay for HPV detection. And he was one of the early scientists to work with NGS technologies and apply NGS for several research and clinical applications. He has co-developed many proprietary technologies and assays for STI pathogen detection and cancer diagnostics at ChapterDx, an NGS assay development company located in Menlo Park, California. As you can hear, Dr. Baback has an astounding credentials, and we look forward to learning more about this novel assay. Over to you, Dr. Baback.
Thank you, Jean, for the presentation, for presenting me, and thank you for inviting me to this webinar and arranging this webinar. So I'm going to start with my slides. Let me see if I have access to share my screen. Oh, yes, I do. Very good. So as Jean said, we have developed an NGS assay for detection of a wide spectrum of sexually transmitted infections. And this assay detects 43 pathogens, 28 HPVs, and 13 STIs. And it actually it's 43 targets, but we genotype and type 41 sexually transmitted infections, including HPV. So first, I would like to talk about the global incidence of sexually transmitted infections. As you know, this number is mind-boggling. 1.1 billion people, as we speak now, are infected with sexually transmitted infections globally. And HIV is not included in this number. And in the United States, we have 20 million new cases per year and 110 million existing infections. And as we know, many of these sexually transmitted infections are symptom-free and silent infections, and they can cause serious and fatal health consequences. According to WHO, we have 376 million new cases of just these 4 infections per year: syphilis, gonorrhoeae, Chlamydia, and Trichomonas vaginalis. And also we have 530 million genital herpes cases and also 290 million new cases of HPV per year. So, and also the congenital syphilis in children, in babies, is 661,000 per year. And of these 200, we have 200 stillbirth or newborn deaths, actually. So this is to say that sexually transmitted infections, they are very common, and we also see that many individuals have a multiplex of these infections. So another thing that I would like to cover is that we know very little about the association of these sexually transmitted infections with each other and how they cause cervical cancer. There are many studies that show association between HPV and other sexually transmitted infections as cofactors for HPV-mediated cervical cancer. So HPV in itself is not inflammatory. So it's not very highly inflammatory. And then usually with a co-infection like chlamydia or gonorrhea, that the inflammation causes the HPV to cause cancer, actually. So there are studies, for example, showing that a co-infection of HPV with Chlamydia trachomatis or genital herpes is associated with a greater risk of developing cervical cancer. And actually, just having genital herpes or HSV2 increases the chance of acquiring HIV threefold, 300% actually. The HPV co-infection with Neisseria gonorrhea also increases cervical cancer risk, and HPV co-infection, for example, with HSV2 also increases the frequency of HPV-16 integration, which in itself may cause cervical cancer. Also, another study shows that HPV co-infection with Trichomonas vaginalis or Gardnerella vaginalis are also associated with cervical lesions in epidemiological studies. And also Ureaplasma parvum load, the load of this bacteria, Ureaplasma parvum, was also higher in women with cervical lesions compared with women without lesions. So this is just to say that HPV in association with other STDs, they may act as cofactors for causing cervical cancers. Another thing that I would like to mention is that Pap test is being replaced by primary HPV testing. The reason for that is Pap test is, HPV testing or HPV screening is more sensitive because we detect the virus. The Pap test actually looks at the morphology of the cells actually, the Pap test could have a lot of errors, and there are normal cells that could look like abnormal cells or vice versa. And also it requires skilled workforce like hepatologists or cytologists to look at these. And it's a very objective, it's a very subjective test. And also using HPV assay, we detect the virus much earlier. And the negative test of HPV test has a greater protection for a longer period of time. So right now, every 5 years, that would be, that's the regulations in US. So women between, I think 25 or 30 to 65, every 5 years, they can be tested for screening of HPV. And many countries have already adopted HPV testing, and more countries are added. This is a little bit old, so I don't know if there are new countries right now. And even Turkey, as a low and middle income country, has they analyze, they look at 1.5 million women per year now for HPV testing. So the assay that we have developed detects 41 sexually transmitted infections. As you can see here, we detect 18 high-risk HPVs and 10 low-risk HPVs. And also here, we have also 13 other sexually transmitted infections. Of course, not all of these are clinically very important. I mean, low-risk HPVs, they cause genital warts. They don't cause cancer. So clinically, they are not as important as the high-risk HPVs that cause cervical cancer. So, but we decided to include all of these because a lot of people would like to know if they have low-risk HPVs that cause genital warts. And basically, this assay gives us a 360 overview of what's going on with the sexually transmitted infections in an individual or a patient. And I've been working with HPV detection for over 20 years, and I was always thinking, why not develop an assay that detects everything? And we don't need to go test STIs one by one or in smaller multiplex, like for example, Chlamydia, gonorrhoeae together. Why not detect everything in one assay at a low cost? And to best of my knowledge, this is the first assay can detect all these in one tube actually. So the assay that we have developed is it genotypes and also quantifies. It's amazing that you can quantify 41 STIs in one tube actually. So it genotypes and quantifies 28 HPVs and 13 STIs, as we mentioned. It's a single tube and single PCR reaction test. The barcoding is innovating. I'll explain and I'll explain that later once we go a little bit further in the slides. And it's very cost efficient, it's user friendly, and also it's very easy to automate. And it's suitable for low, medium, and high throughput scales. The laboratory that is planning to run this assay, they actually require minimal and affordable laboratory equipment. Nowadays, Illumina sequencers are not very expensive. They are probably, they cost as much as a real-time PCR instrument. And the consumables that are used for this assay, they're very affordable. And also we have developed a software that comes with a kit that is user-friendly data analysis software. And also the kit includes indexing, library preparation, and also the data analysis software. So this is how the assay works. We have all the target specific primers, 28 for HPV, 28 primer pairs for HPV, 13. Actually, it's more than 28. I think it's 29 HPV, yeah, 29. And here we have 14, I think, 14 STI primer pairs. I'll explain that later. And also we have the barcodes, separate barcodes, and also the internal control primers for the, this is for cellular internal control primers. And what happens when, and also the PCR components, all in one tube or one well. So how it works is at the same time that we amplify the targets, the targets get barcoded in this sample. So there is no need for additional steps for barcoding or indexing. So barcoding and amplification, they occur simultaneously in this well. So here is an overview of the technology. First is the DNA extraction, which is universal. And then it's the PCR. And as we mentioned, barcoding and PCR, the amplification, they take place in the same well. And I'm sorry. And once the PCR is performed, it takes usually between 1 or 2 hours, depending on the assay. For the HPV assay, it's about 2 hours. We pool all the samples. So it doesn't matter if we have 96 samples or 2,000 samples or 384 samples. We pool them all in one tube. And from here, it's very easy. It's just, we take a vial and we purify it. And then the rest is a standard Illumina sequencing. And we let it go overnight. So if we start in the morning and so in the next day when we come to the lab, the results are ready. And the data analysis software usually takes about 10, 15 minutes to half an hour, depending on the computer that you use. And the total bench work, including the incubation times, is about 3 hours, all the way to the library preparation and when the library is ready for sequencing. This is the simplest NGS assay you can think of. Usually NGS assays, they have multiple steps. This is very simple. As you can see, it's one PCR, pool, and then you go for sequencing. These are the external analytical performance. We received these samples from Sweden. These are the WHO proficiency HPV testing. So we received these, and these are blind samples that they send you, and you send them the results, you get the results later. So as you can see here, they have single HPVs. These are plasmids, HPV plasmids, and multiple infections of HPVs. And our assay has been able to detect all of them, and with very good sensitivity and specificity. And the detection limit for these assays was 20 copies. And we have developed our own synthetic controls as well. And also for those, the detection limit was 20 copies. And if you look at the numbers here, there are 200 copies, and you can see the numbers are very close to 200 copies. And so you can actually quantify these as well. And of course, you can never get them around 200. As you know, there are many, we have PCR errors and we have dilution errors and all that, but these are very, very, very good numbers that are very close to 200. So we have compared the Chapter DX HPV STI assay with Roche HPV test. Roche HPV test is FDA approved, and we have published this HPV this sample cohort that we analyzed, and it was recently published ago, I guess. Yeah, I think it was 2 months ago. And so it was a blind test. So we received these samples, and actually these samples, when we received them, they were a few days also at the customs in room temperature, and we weren't sure if they were going to work, but they worked very well. So DNA is pretty stable even in room temperature. So Roche Cobas detects 16 and 18. Sorry, I mean genotype 16 and 18. And the other 12, it just screens them. You don't get the type or how many infections there are. You just get it as a positive or minus for these 12. But it genotypes 16 and 18. The Chapter DX assay types all of these 41 STIs here. So the comparison with Roche, we had an overall agreement of 97.5%, which is very good. And for HPV 16 that Roche detects, we had 98.5% agreement with Roche. For HPV 18, we had also 98.5% agreement. And for the other HPVs, we had 96% agreement. And for the pre-cancers, SIN2 and SIN3, there were 58 of those that we detected all these, that we detected HPV in all these pre-cancer samples. And there were 3 cervical cancer samples as well. We detected the HPV in all these 3 cervical cancers as well. And But what was interesting about this assay was that these samples had only been tested by Roche Cobas for HPV, and they had not been tested for sexually transmitted infections like chlamydia, gonorrhoeae. But as you can see here, we also detected chlamydia, Trichomonas vaginalis, Mycoplasma genitalium, HSV2, and so on. So we detected other sexually transmitted infections other than HPV that otherwise they had gone undetected. And here are actually some of the results. I have cherry-picked them. These are the Roche Cobas results, and these are the Chapter DX results. So if you look at the first one, Roche Cobas is HPV 16 and others. Others is 12 types. We don't know which ones, but there's one or a few of those. And we have detected HPV 16, 35, Trichomonas vaginalis, Ureaplasma parvum, and Mycoplasma hominis. Roche's others, we have detected HPV 33, 56, Trichomonas vaginalis, Mycoplasma hominis. Roche's HPV 16 others, 16, 18 and others. And we have detected 10 HPVs here actually, including HPV 16, 18. And also Trichomonas vaginalis, Mycoplasma hominis. I will get back to the sample in the next slide. And here is, for example, Roche's others. We have detected HPV 58 and Chlamydia trachomatis. So, these patients like that have chlamydia, they go undetected actually. And so on. I mean, here is others, HPV 35 plus herpes simplex 2, HSV2. So back to the sample tree in the next slide. So as you can see, the sample has 10 HPV infections, including Trichomonas vaginalis, Mycoplasma hominis. Roche results are 16, 18, and others. So I looked at the results because it was a blind test. I didn't have the results. And once I looked at these high reads, these are reads, sequence reads, and it was very high compared especially to the GAP-DH control. I don't have the GAP-DH results here, but they're much higher compared to the GAP-DH results. So I was guessing that this patient might be pre-cancer or cancer. So once we received the results for this assay, we found out that this sample was a HSIL in cytology and histology SIN3, which is a pre-cancer, very close to cancer actually. So viral load actually, there are many articles that show that they are predictor of status of disease such as pre-cancer or cancer actually. And so we haven't done much studies for the viral load, but it's for groups that want to do research, that would be a very good tool actually. And also extended genotyping is very important nowadays, just 16 and 18. They are the most important types, but there are other types that are important. Right now in the Roche, they detect 14 types, but there are types 16, 18, 31, 33, 50, 35, 45, 51, 52, and 58 have higher positive predictive value than the HPV 39, 56, 59, and 68. So knowing the type is important. And also there are articles from QSIG that shows that HPV 31 and 33, they have a very high positive predictive value for SIN2 and SIN3, and they are as important as HPV 18, for example. So extended genotyping or knowing the other types is becoming more and more interesting. And recently, an assay by Becton and Dickinson, a VD, they got approval for extended genotyping by real-time PCR. But they don't do all the 14 genotypes, just do a few of them. And they do it in 3 wells instead of 1 well. So they have to use 3 wells. So it's also a little bit limits the high throughput screening. We have also compared Chapter DX HPV STI with Genomic Clart, which is a European test from Spain, and it's a CE-IVD kit. And this assay detects 35 HPVs. So the overall agreement with Genomic Clart was 98.7%. And we had 75 samples for this study cohort. We detected Chlamydia, trachomatis in these samples, Trichomonas vaginalis, Mycoplasma hominis, and Ureaplasma parvum. And there was only one sample that there was disagreement, and we detected HPV, I think 58, and they detected 52. And this might have been a typo from the samples that we got from our collaborators. So this might be not a disagreement, but still clinically, it's not a disagreement because the treatment would be for type 58 and 52 the same. So. And what was interesting when we compared ChapterDx HPV STI assay with the Genomic Clart was that we detected more HPV types. For example, in these 75 samples, we detected 25% of the samples, we detected more types in 25% of samples, high-risk HPVs. We detected in 9% of the samples, other low-risk HPVs. And also we detected a combination of co-infections of low risk and high risk in 8% of the samples. So if you look at it, in 42.7% of the samples, we detected other high risk and low risk HPVs that they were not detected with the Genomic Clart. So if you look at some of the results, so what they do, these samples, they had looked at them with a hybrid capture 2, which is a QIAGEN hybrid capture 2, which is a FDA approved test. And it doesn't give you genotypes, it just provides the screening results, positive or negative. So once they are positive, this lab looks at these samples with Genomic Clart, which detects 35 types, and these are the results. And so we analyzed them with ChapterDx results. And as you can see here, and those samples that were PCR inhibited, they have PCR inhibition with Genomic Clart, they use another kit, real-time PCR kit, or if they were false negative, because here they were positive in hybrid capture 2, but here they were negative. So they had to use another test, this lab. So they used a real-time PCR test and for genotyping actually. So as you can look at the results here, Genomic Clart was detected HPV 62, which is not a high risk, but hybrid capture 2 has detected a high risk, but here is not a high risk. So this lab used another kit. So they used 3 kits actually. And they detected HPV 45, by real-time PCR. But by ChapterDx, we detected HPV 30, HPV 45, which they detected, actually this assay detected, and they did not detect. And then HPV 62, which Genomic Clart detected, plus Mycoplasma hominis. So, and also the second sample was positive with hybrid capture 2. It had PCR inhibition with Genomic Clart. We detected HPV 51, Chlamydia trachomatis, and Neisseria gonorrhoeae. This is a serious sample. It has high-risk HPV and 2 also serious STIs. And as you can see, it was confirmed also by the real-time PCR assay that it was HPV 51, and so on. I mean, here is hybrid capture 2 positive, the 3 types detected by the Genomic Clart, but here we detected the same types that Genomic Clart detected, plus HPV 87 and Chlamydia trachomatis and Mycoplasma hominis. And the gain here is, you can see here, 3 types detected by Genomic Clart, and we detected 1, 2, 3, 4, 5, 6 types here. And same here, as you can see, negative, but positive with hybrid capture 2. And we detected HPV 56 and 68B, and the same here, HPV 56, HPV 68. Plus we detected also Mycoplasma hominis. And let's look at this one also, which is, and here is another one, HPV 18 to 83. We detected 1883, and this patient had also Trichomonas vaginalis. And here is negative, false negative, but here we detected HPV 6 and 45, Mycoplasma hominis, and it was HPV 45 confirmed by real-time PCR, and so on. I mean, here is another negative. We detected HPV 35, 51, and also the real-time PCR detected HPV 35, 51. So as you can see here, for example, the last one has 2 types, and we detected 6 types. So we detect also more types. The reason for that is this assay, Genomic Clart, they use general primers, and general primers, they use probably 2 or 4 primers. As, and these are general primers that they do not have the same affinity for each type. They amplify one type better than the other one. And also it also causes type suppression because it amplifies one type better than the other one. So some types are suppressed in the amplification. So ChapterDX assay uses type-specific amplification. So for all the 43 targets that we amplify, we use target-specific primers. That's one reason we detect more types. Another issue that I wanted to bring up here is the STI samples. These are non-HPV samples. Up to here, we were showing HPV sample results, but these are STI samples that we analyzed by HPV STI NGS assay by ChapterDX. And what is interesting that these are from a microbiology lab, and many of these samples that we received, 100 samples, about these 100 samples, 40 of them had HPV infections, and they go undetected, these HPV infections. I'm just going to show you a few of these. These are the specimen from if they're cervical, vaginal, and so on, condyloma. And if you look at it, they use PCR, and with PCR, it was Chlamydia trachomatis. We detected Chlamydia trachomatis LGV1 and plus Mycoplasma hominis. But the sample also had HPV, the HPV that we detected by ChapterDX. I separated them so we can see clearly. HPV 31, 33, 51, 3 high-risk HPVs actually. And here is Chlamydia trachomatis again, and it's a cervical sample. And here is Chlamydia trachomatis, HSV2. As I mentioned, HSV2 increases the chance of acquiring HIV by 3-fold. Mycoplasma hominis and Ureaplasma parvum plus HPV 11 and 42. These are low-risk HPVs. So if you see here, but the PCR, they detected HPV trachomatis, and we detected 1, 2, 3, 4, 5, 6 other, including HPV, 6 STI and HPV. Here is Neisseria gonorrhoeae, vaginal sample. As Neisseria gonorrhoeae, we have detected Ureaplasma urealyticum. Plus, we have detected HPV 45, 51, 52, 44, and 83. And so these are just to show the advantage of just using one assay and detect everything, because even if we use these single PCR assays or dual PCR assays or just HPV multiplex assays, we still miss STIs or vice versa. And here is Chlamydia. Or let's look at this one. This is Neisseria gonorrhoeae. And you can see here Neisseria gonorrhoeae, Mycoplasma hominis, Ureaplasma parvum. And we have also detected HPV 6, 18, 51, 68A. We differentiate between 68A and B. 6, 44, 61, 83. So, and here is Chlamydia trachomatis, and we have detected trachomatis, Chlamydia trachomatis, and Neisseria gonorrhoeae, Ureaplasma parvum. This is also serious sample plus HPV51, and so on. Let me see if I find something more interesting. Yeah, here the last one actually is Chlamydia trachomatis. We have detected Chlamydia, LGV1. This is usually when they detect Chlamydia, they do another PCR to detect the serotype of the Chlamydia. Sorry, not PCR, sequencing. They do Sanger sequencing. So it's a lot of work actually. It's first when you detect Chlamydia, they have to do Sanger sequencing to detect which serotype it is. But in this assay, we just get the serotype LGV1. And the sample has Trichomonas vaginalis, Mycoplasma hominis, Ureaplasma parvum, and Ureaplasma urealyticum, plus HPV 66, which is high risk as well. And this one is Trichomonas vaginalis. They have detected it with PCR. We have detected that plus HPV 18 and 55. So showing both the HPV results, we show that many HPV samples have other sexually transmitted infections, and here also showing with the non-HPV STI samples that many of them also harbor HPVs. There are 100 samples that we received that were positive. For 40% of them, 40 of those had HPV infections. And in this slide, I would like to show you that the consumables are very affordable for this assay. Of course, these are US prices. These prices are different in other countries. So, and also these are last year prices. So I'm sure these prices have changed a little bit because of the inflation. But if we use a mini-seq in our lab for sequencing and using a mini-seq, so if we have 200 samples, so the total cost per sample would be, including sequencing and consumables, would be about slightly over $3. If it's 100 samples, it's $6. So the more samples you have, the cheaper it would become. But the consumables are very affordable. And for MySeq, also 100 samples would be, per sample would be 4.66, which is including that includes the sequencing, and also for 200 samples, if you have, so the cost would be about $2.40. So the consumables are very, very affordable. And also many laboratories that do an STI testing just for HPV and 6 STIs for FDA approval tests, they have to get 4 kits, one for HPV screening, one for Chlamydia and gonorrhea, one for HSV1, HSV2, and one for Trichomonas vaginalis and Mycoplasma hominis, and that's 6 plus HPV. And also if there's HPV is positive, usually they use another kit for genotyping the HPV because they don't get all the genotypes. They, for example, for Roche, they get only 16 and 18. However, with Chapter DX, we detect all 41 STIs in one tube, and it includes the internal control, and it's also quantitative, and it's very low cost. So this is my last slide, and the Chapter DX assay for HPV and STI is a single tube reaction where the barcoding and indexing takes place in the same tube, and it covers a wide spectrum of sexually transmitted infections. It's quantitative, type specific. It has an internal control. It's good for low to high throughput scales. Also, it's very cost efficient. The bench work and incubation time is about 3 hours, and it has a simple workflow and is easy to automate. So I'll be happy to answer your questions, and thank you for your attention.
Thank you very much, Baback. That was really impressive presentation. It just shows the importance of a comprehensive assay and being able to identify co-infections, how clinically relevant those co-infections are. I see that there has been a question already posted in the chats box. Let me just read that out to you. The first question would be, under the warnings and cautions in the manual, it mentions that there's a step 18 that recommends doing a gel electrophoresis after the amplification step. The attendee would like to know, how important is that step?
To do the gel electrophoresis?
Yes, after the amplification step.
Yeah, it's just it's just to make sure that we have amplification and everything has worked. And if you can do a gel electrophoresis or a bioanalyzer testing, that would be good. So it just shows that you make sure, because it's if there's an issue, for example, something wrong with the amplification, and you go sequencing, the sequencing is expensive, and then you have to redo the whole thing again. But with just a bioanalyzer, which is the best one actually, bioanalyzer or the PCR test, you just know that you have got amplification or not, everything has worked well. So it's just a control, just to make sure that the PCR has worked. We would recommend it, before going to sequencing, just to make sure it has worked.
Okay, thanks, Baback. And then part of the same question was in step 21 of the workflow, it says to purify the amplified library within 1 hour after the amplification. They would like to know, does this mean that you cannot leave the PCR products overnight on the thermal cycler or freeze them immediately afterwards?
Oh, no, we don't recommend leaving it on the thermocycler. And after you can actually freeze it if you don't want to continue with it after you pool everything and with the Q buffer, you pool and everything, you can just freeze it actually. It's in the manual, I think. And you can just freeze it and work with it later.
Okay. And then part of the same question was the sample barcode Excel file and chapter diagnostics analysis. Is this available to all users and customers? And I think you did touch on that during the presentation, that it is included with the reagents that you would purchase for this particular assay.
For the software, you said, right?
Yes.
Yes, yeah. The software is actually very easy to use, and it's very simple. And also the software, you can easily download all the results as a Excel file or CSV or Excel file, and you can just download it, and you have all the results, and also it's customizable how you want to get the results. And we for South Africa, we have this software free for all the users that they want to use it. Yes.
Okay. And then they've also asked, what is the internal control that is used with the kit?
Oh, it's GapDH. So it's for human DNA. So GapDH, and usually that shows if if we have the PCR has worked or not. And actually, it also shows it's very interesting, because I just received some results from Spain, and there was one sample that had very little amount of DNA, extremely low. It was like 0.3 nanogram per microliter. So, and you could see it also the results in the GapDH. The GapDH was usually just 11 reads, which is very low. I mean, usually expect it to be in a few hundreds, just a few hundred reads, but just 11, and you could just see the relationship between the DNA content and the GapDH sequence reads.
Okay. And the final question was, the assay suggests using your own DNA extraction kits of choice. They're just asking, which extraction kit would you recommend?
I think the reliable kits that are out there, like QIAGEN, Roche, and other companies, they work. But I would recommend that they use something that generally gives a good yield, and so that's our recommendation. QIAGEN kits could work well. There is QIAGEN Mini. I know a lab that I can share the protocol. that they actually, to increase the yield, especially with problematic samples, they just let it to go overnight. They have their protocol, and then they use it the next day. And they get a lot of yield, actually. They centrifuge and get the pellet. But QIAGEN is good, QIAGEN Mini, and I think QIAGEN Micro is even better, yeah, than Mini. QIAGEN Micro, that's a good one. But there are many other kits. I would recommend that you just test them, the kit that would work with your samples, and just test it, because I know for some laboratories cost is very important, and some kits like QIAGEN, they're expensive, so there are other kits that are more affordable.
Yeah, 100%. And then the last message was actually just more of a comment, and it was just a person thanking you very much for the presentation on this comprehensive assay. But I think if there's any other questions, you're welcome to unmute yourself and just ask Baback directly. If not, you are welcome to mail separations with any additional queries that may come to mind after viewing this presentation. And yes, and then I think that comes to the end. Thank you everyone for attending this webinar. And thank you, Baback, for presenting.
Oh, thank you. It was,
thank you so much. Thank you.
Thank you.
Thank you. Thank you. Bye.
Thank you.
Thank you, everyone.
Bye-bye. Bye-bye.
Thanks so much.
Thank you. Bye.